The loss of control over the battleship Warspite began with a catastrophic physical mismatch between aerodynamic drag and the tensile strength of heavy steel. In April 1947, a severe gale transformed an unpowered former battleship of about 31,000 tons into a deadweight missile, trapping 8 caretaker personnel aboard a drifting hull. The initial salvage operation relied on the naval tug Bustler and a second heavy tug to pull the decommissioned vessel toward the Clyde. Under normal conditions, heavy steel towing hawsers possess adequate, safe working loads to maintain forward momentum and keep a dead ship in line. But a battleship stripped of its main propulsion is a dynamically unstable object. Without engines to govern its heading, the vessel cannot turn its bow into the weather. When a severe southwest gale intercepted the convoy off the jagged coast of Cornwall, the fundamental geometry of the dead ship turned against the towing crews. The dreadnought design featured a towering armored superstructure, multiple gun directors, and heavy deck plating meant to command the horizon. In a severe gale, this vast above-water surface area acted as a massive, rigid sail. As the wind velocity increased, the broadside generated extreme lateral drift, pure windage acting on more than 30,000 tons of helpless steel. The load now attacked the tow at the worst possible angle, forcing a forward pull system to behave like a storm anchor against the ship's side. The vector forces rapidly escalated. When a thick, steel-towing hawser approaches its breaking strain, the failure is extremely violent. The hawser stretched to its elastic limit, then passed beyond recoverable strain. The main tow line from Bustler parted under the immense shock load. Facing the risk of being dragged backward and capsized, the crew of Matinda Thurs slipped their own towing gear. The tether was completely severed. The operation failed instantly. The hull was loose in the storm. The immediate crisis shifted away from vessel recovery and focused entirely on human survival. The 8 men aboard remained trapped on the unpowered hull. They had no engines, no steering gear, and no means to halt the relentless drift toward the Cornish coast. An anchor was dropped in a desperate attempt to arrest the slide. For a moment, the act looked like the last available piece of control, a heavy fluke, a massive chain, and the hope that the seabed would hold. But in storm force conditions, the anchor did not hold. The old ship broke free of it, and the gale drove her toward Mount Mopus Ledge and the rocks off Prussia Cove. Extracting a trapped crew from a dead dreadnought in a gale is a problem of lethal geometry. The hull of a battleship is a sheer vertical wall of hardened steel, plunging deep into the water and violently rolling with the chaotic sea state. Approaching the shifting mass requires exact mechanical timing. The Penlee lifeboat intercepted the stranded warship as she lay among the coastal rocks. The rescue crew worked in breaking seas reported at roughly 25 feet. In a severe coastal storm, the crest of each wave could lift a small rescue boat toward the warship's deck, followed immediately by a sheer drop into the trough. The lifeboat coxswain had to hold his vessel alongside the towering hull without being crushed beneath the rolling mass or smashed against the steel plating. The coxswain had to counter gale, surge, and rebound while each trapped man crossed from rigid steel to the pitching lifeboat at the brief instant the two decks aligned. Through highly disciplined boat handling, the rescue crew systematically brought all 8 men off the doomed ship. The extraction was flawless, removing the human element entirely from the equation. What remained was a purely mechanical and physical failure. With the crew safe, the remaining question was where the storm would put the wreck, and how violently the coast would receive it. The collision between more than 30,000 tons of unpowered naval armor and the rocky Cornish coast created a different kind of trap. When the drifting hull was pushed shoreward, it did not encounter a yielding beach of mud or sand. Around Mount Mopus Ledge, Cudden Point, and Prussia Cove, the coast presents hard ledges, fractured shore platforms, and rock outcrops shaped by slate, metadolerite, and gabbro, rather than a single simple mass of granite. This coastal shelf presents a series of unyielding underwater ledges and jagged points. A dreadnought is engineered to spread battle damage from shells and torpedoes through armor, frames, and watertight subdivision. Grounding reversed that protection logic. The reef drove force upward into the lower hull through the ship's own weight. The destruction was severe, but the surviving accounts do not support a precise forensic inventory of every failed plate, rivet, and frame. What is clear is that Warspite's bows were ripped open, compartments flooded, and the ship settled down by the bow. High seas lifted her from the first ledge and drove her farther inshore, leaving her fast among the rocks off Prussia Cove. This severe structural compromise forced an immediate and permanent shift in the operational objective. Metal Industries had originally expected to cut the vessel up at Faslane after a long tow north to the Clyde. That plan depended on an intact floating hull, not a warship with open damage, flooded compartments, and her bow down among rocks. The engineering judgment was brutal and simple. Warspite was too badly damaged to be taken on to Faslane as planned. Several attempts to refloat her failed, and the original deep water tow ceased to be the governing objective. The dead ship could not be treated as a normal hulk bound for an industrial dismantling facility. This left the salvage engineers with a singular, immense problem. Since the battleship could not be transported to a ship-breaking yard, a heavy industrial scrapping yard would somehow have to be improvised directly atop a shattered, heavily flooded wreck stranded in an active coastal surf zone. In 1950, Salvors made a dramatic attempt to restore enough buoyancy to move the wreck. 24 compressors were brought into the operation to pump air into the ship's tanks and flooded spaces. The idea was not to dewater the battleship in the clean, controlled manner of a dry dock. It was to use compressed air to displace some of the water inside the damaged hull and give the wreck a temporary margin of lift. The practical details remain thin in the surviving public accounts, so the safe conclusion is narrower than the legend. Air was forced into parts of the hull to assist refloating, while the crews worked under the limits imposed by broken structure, shallow water, tide, and weather. The operation was a salvage attempt, not a stable conversion of the whole battleship into a predictable pneumatic caisson. The compressor operation produced drama, noise, and public attention, but it did not produce the clean mechanical victory described by rumor. The Salvors could not simply raise the shattered hull clear of the reef and tow it away. The surviving accounts state that the refloating attempt failed because there was not enough depth of water to float Warspite clear, and the weather was still against the operation. That failure changed the physics of the problem again. Compressed air could assist the work, but it could not erase the shallow reef, the damaged hull, or the gale. The ship remained a wreck that had to be moved in short, difficult stages rather than restored to a reliable deep water tow. A badly damaged, partially flooded dreadnought in an active coastal surf zone represents an immense kinetic hazard to any lighter vessel attempting to work around it. The 1950 salvage effort did not unfold as one clean, coordinated deep water tow. It became a sequence of attempts, failures, and near disasters around Prussia Cove, Mounts Bay, and the approaches to Marazion. The named vessels in that sequence should be kept in their proper roles. Barnet was a salvage vessel standing guard under Warspite's bows during the failed compressor-assisted refloat. Masterman and tradesmen entered the record in later towing work, when the operation was still struggling to shift the hulk through shallow, rock-strewn water. The common factor was not a single tow formation, but the same uncontrolled mass, a dead battleship with no engines, no effective steering, and far too much inertia for the local weather and water. When a heavy wave set strikes the massive broadside of a 33,000-ton hull, the entire steel structure begins to sweep laterally across the water. The kinetic energy generated by this sheer mass in motion is staggering. The towing tugs connected by heavy steel hawsers must rapidly apply counterthrust to arrest the swinging motion. If the tug lacks the immediate engine horsepower to halt the sheer lateral slide, the dynamic suddenly reverses. The towing vessel is no longer pulling the warship. Instead, the dead dreadnought becomes the active mechanical engine, physically dragging the smaller ships. During the failed compressor-assisted refloating attempt, Barnet was caught in the worst possible position, standing guard overnight under Warspite's bows. The heavy bow loomed above the smaller salvage vessel as the sea continued to work the wreck. Barnet was holed in the engine room, then towed off. She did not become proof of a perfectly reconstructed towing bridle failure. She became proof that even a supporting vessel near the bow of the stranded battleship was operating inside a lethal impact zone. The damaged salvage vessel eventually drifted ashore at Long Rock, a few miles to the west. The human lesson was immediate. Around Warspite, proximity itself had become dangerous. The later November work produced another failure, but the sequence was different. The Falmouth tug Masterman spent the night on Hawgers Rocks after failing to tow Warspite. Her sister tug Tradesman was damaged while trying to haul Masterman clear when 60 feet of wire became wrapped around her propeller. The exact hydrodynamic sequence is less certain than the outcome. What can be stated safely is that the salvage effort was damaging its own support craft. The wreck was still too heavy, too awkward, and too trapped by shallow water and rocks to be handled as an ordinary tow. The repeated failures forced the Salvage Command to accept a smaller, harsher objective. Instead of treating Warspite as a ship that could be carried away to a distant yard, they would move the hulk only as far as the nearest workable beach. By August 1950, the battleship was finally beached off St. Michael's Mount. That did not end the struggle. Further salvage work followed, and another attempt to shift the wreck came in November. Assisted by compressed air and even jet engines from an experimental aircraft, the hulk was eventually moved about 130 feet closer to shore, onto Marazion Beach, between St. Michael's Mount and Hawgers Rocks. The achievement was not a graceful lateral delivery across the tide. It was a hard-won series of short movements, each dictated by shallow water, rock, weather, and the stubborn mass of the wreck. Once Warspite was brought into the beach environment, the character of the problem changed. She was no longer a realistic candidate for a long tow to Faslane. She had become a fixed industrial problem in the open air, a dead battleship close enough to shore to be cut apart piece by piece. The deliberate shallow water grounding successfully stabilized the wreck through sheer gravity and friction. It could no longer sink beneath the waves, suddenly swing off axis, or act as a massive kinetic weapon against the local fleet. The ship was utterly immobilized, firmly embedded into the coastal geography. The Salvage Command had successfully transitioned the project from a chaotic nautical rescue into a completely static demolition environment. However, delivering a 33,000-ton steel fortress to an open sandy beach did not dismantle the high tensile armor plating. The engineering team now faced the immense logistical reality of cutting apart a massive, armored Leviathan entirely without the heavy cranes, deep water basins, and controlled infrastructure of an established dry dock. Dismantling 33,000 tons of high-tensile naval armor in an active coastal surf zone is an industrial process entirely dictated by the shifting tide. Unlike a controlled dry dock environment where water is permanently excluded and heavy, dockside infrastructure surrounds the vessel, a beach scrapping operation is continuously interrupted by the ocean. The salvage engineers who anchored the dead dreadnought to the sands of Marazion faced an absolute environmental time window. They would spend 5 years systematically erasing the massive steel fortress, racing against the daily encroachment of the sea. Scrapping a heavily armored warship outside of an industrial basin requires extreme logistical endurance. The ocean tide operates on a strict lunar cycle, meaning the lower sections of the hull were only exposed to the cutting crews for a few hours each day. When the tide receded, the workers swarmed the wet steel, igniting heavy oxyacetylene torches to slice through the thick armor plating and rigid internal frames. The moment the tidal surge returned, the lower work zones flooded. The crews were forced to retreat to the upper decks, completely abandoning the lower cuts until the water level dropped again. This relentless stop-and-start rhythm defined the daily reality of the demolition. The most severe limitation of the beach environment was the lack of normal shipyard infrastructure. In a standard scrapping yard, heavy cranes, rail links, and controlled work areas support the dismantling of a warship. At Marazion, the salvage team had to improvise around sand, tide, and exposure. One of the most striking solutions was to use Warspite's own seaplane crane as part of the lifting effort. Utilizing the ship's crane gave the demolition a grim internal logic. As cutting teams severed scrap sections from the hull and upper works, the crane helped lift pieces over the side. The sections were then moved into the shore transport system and sent onward for smelting. The dead ship was, in a very literal sense, helping to lift parts of itself away. The demolition progressed relentlessly from the highest gun directors down toward the deeply buried keel. Over the span of 5 years, the towering superstructure was reduced to a flat deck. The heavy-side armor was peeled away, and the internal honeycomb of watertight compartments was sliced open and removed. As the physical mass of the warship decreased, the remaining lower hull settled deeper into the yielding coastal sand. The cutting teams followed the steel downward, digging deep trenches around the perimeter of the wreck during extreme low tides to reach the lowest double-bottom plating. Through sheer industrial endurance, the visible destruction of the vessel was finally achieved. By the mid-1950s, the great shape that had dominated Marazion Beach had disappeared from view. Her armored decks, upper works, and accessible scrap had been cut away, lifted, and carried off. But the ending was not absolute. Traces of Warspite remained in the sand of Mounts Bay. The boilers could not be removed intact, and fragments remained deeply embedded beneath the beach after being broken up. The operation was still an immense technical achievement. The visible maritime hazard was neutralized, much of the valuable steel was recovered, and the towering armored Leviathan was erased from the coastal horizon. But the grand old lady was not completely obliterated. Parts of her were left behind, buried beneath the Cornish sand.